Hey guys, welcome back. Let's go ahead and take a look at how to configure an Ether channel or a port channel in this particular video. Very simple video. We're going to take a look at the topology that we looked at in the previous video and try to set up some of those links as static Ether channels or port channels. So the three main things in this video: Ether channel static setup, what are the different configuration commands, and then the actual lab to set it up. So again, to recap, EtherChannel static mode basically allows you the ability to specify that this particular, interface is part of an EtherChannel. I'll link the multiple interfaces that are part of the same EtherChannel by using an EtherChannel or a port channel number. You need to manually make sure that the ports on both sides are correctly configured as EtherChannels. All right? So this is your responsibility. It does not do any type of negotiation. No packets are sent to negotiate between the two switches in this particular setup. Again, as I said earlier on in the earlier video, the problem with the static port channels is that if one of the sides unbundles a port channel, like unbundles a physical link, and the link is up, the partner does not know that has happened. So the partner will keep on sending traffic over that link because the link is still up. So he thinks the link is up, it's still part of the port channel. I'm going to keep on sending traffic on that interface. So that's where the drawback comes in. All right. So how do I configure it? In order to configure a port channel, the way you do that, a static port channel, you go in and specify the 2 interfaces, 3 interfaces, 4, whatever number you want to bundle together. In my case over here, let's take a look at the topology. It's the same topology from the previous video. I want to connect up, let's say, port switch 1 and switch 2 in a port channel. So the two ports that I want to bundle up over here are gig 00 and gig 01, which connects to the other switch 2, gig 00 and gig 01. So these are the two ports that I want to bundle up. So in order to do that, what I do is I go to the two ports, interface range, gig 00, gig 01, channel mode or channel group, XX, a number, a numeric number, locally significant, mode on. Mode on is your static. And I would need to do the same exact thing on the other side. These again are locally significant. So whatever number you specify, if you wanted to, you could do this over here as 12 and I could do this as 21. It's absolutely okay. But as soon as you do that, whatever number you pick, it will automatically configure or create a logical interface called the port channel interface. Port channel interface is a logical interface and it'll have the number that you specified as your channel group number. So on switch 1 it would be, let's say, 12, on switch 2 it'll be 21. All right? Once that's done, if you want to configure that link between the two switches as a trunk, you don't do anything under the physical interface. The only thing you do under the physical interface, if I want to trunk between switch 1 and switch 2, is tell it that these two interfaces are part of the same port channel. Once that's done, you go and configure the actual trunking commands under the port channel interface, which is this over here. I should change this to YY just to keep in sync with the example. So interface port channel YY, and then you do the normal trunking commands under the port channel interface, not under the physical interface. All right? So that's how you actually configure a port channel, a static port channel. Now, let's do a lab based on that. Configure a static port channel between switch 1 and switch 2. Port channel ID, use port channel ID of 12 on switch 1, 21 on switch 2. I'm doing it on purpose so that I can show you that this number is locally significant. So over here, the port channel number is 12. Over here, the logical port channel number is 21, which is absolutely okay. What else does the lab have you do? Configure the port channel as a trunk. So once I create it, it'll create that logical interface 12 and 21. I'm going to configure that as a trunk. Configure a SVI for VLAN 10. Configure a VLAN 10 and an SVI for it so that I can actually send some traffic between the two switches. So once this is done, I'll create a logical interface over here on the two switches. 10, 10, 10, 1/24 in VLAN 10. And I'll create the same over here. .2 over here in VLAN 10. That's the objective of the lab. So how do I go about doing it? Let's take a look. I'll do it and then I'll also verify the commands for you. So switch 1, gig 00, gig 01 should be bundled with the number 12 and it should be configured as a trunk. Let's do that part first. So I go to switch 1 over here. Interface range gig 0/0-1. So whatever I'm going to do is going to be done to 00 and 01. Channel group and an ID. It was 12. Mode on. All right. Notice it says creating a port channel. Now, as I said, I don't need to do on this particular device, I don't need to do anything special on a switch for bringing the port up, but I'll do it anyways. Once this is done, I need to configure the port channel. The trunk will be done under the port channel interface. Interface port channel 12, and then the normal switching commands. Switch port trunk, encapsulation, .1Q, switch port mode trunk. Notice the port channel has come up already. Now to verify that, although it's not really operational, but I don't know that, I'm not negotiating with the other side, show EtherChannel summary is a command. And it tells you that you have two interfaces that are part of this port channel. Which are the two interfaces? Member ports are gig 00 and gig 01. P over here, the legend for that is right at the top, bundled in the port channel. Bundle means, or P means it's up. All right, the ports are actively bundled in. The name of the port channel is 12 over here. All right, the other thing that I had to do on switch 1 was to do that VLAN. We'll do VLAN 10. I'll turn on IP routing so that I can do the layer 3 functionality. Interface VLAN 10, IP address 10.10.10.1, and no shot. So show IP interface brief, my VLAN 10 interface is up, my port channel is up. All right, so on switch 2, I'm going to do the exact same thing. The only difference is my port channel number over here is 21, just so that I match my configuration on the requirement. Again, the ports between switch 1 and switch 2, gig 00 and gig 01, I'm using the same ports. Channel group 21, mode on. Again, no requirement to do no shot, it's just a habit. Port channel 21. Inside the port channel, trunk encapsulation, .1Q, switch port mode trunk. Normal configuration. The port channel is up. Now the other thing that I need to do over here is that VLAN configuration, VLAN 10, IP routing, create the SVI, the layer 3 interface. It'll say switch 2 is 2, no shot. So let's make sure my interface comes up, show IP interface brief. So you see 10.10.10.2 is up. I should be able to ping 10.10.10.1. There you go. So my port channel is up and running. You can also verify that over here. EtherChannel summary. These two are up. Notice the other thing I want you guys to take a look at over here. It says that the protocol, there's no protocol used to communicate because I did it statically. So that's the static configuration of a port channel. So this was the requirement and these are the commands. Let's make sure the commands are proper. So on switch 1, gig 00, the number of the port channel is 12. Go into the port channel 12, set it as a trunk, turn on IP routing, create the VLAN, create the SVI. Switch 2, same thing. The port channel number is 21. IP routing, create the VLAN, SVI, IP address, and I did the ping to verify it. All right, everybody okay with this? Very simple lab. Now I have a port channel which both my ports are now forwarding over between switch 1 and switch 2. Now the one last thing that I want to show you guys over here is if I do show interface trunk, it shows you that the port channel 21 is the forwarding port. It doesn't say gig 00 or gig 01, it says port channel 21. So STP is treating it as a single logical interface. In the next video, we're going to take a look at how to do the same thing with LACP. Do join us. Thanks for watching.